Thank you. So what I want this talk to be, I've only got 20 minutes, is a really quick overview of very simple, very easy things you can do to tell web browsers to help protect you. This is how you can help us help you and your users. I'm going to talk about this in three ways, three parts. What you can do to improve your security when you're transmitting content, when you're rendering content, and when you're storing content. When it comes to transmitting content securely, there's a three-letter acronym that you have to know. Who knows it? SSL, right. Use SSL. But there's actually a lot of nuance to how SSL is commonly deployed on the web. When you think about the request response cycle that's inherent in the way HTTP works, I make a request to the unencrypted version of your site. Like if I type in example.com into my browser, the first thing that happens is a plain text request to example.com, which will then respond and tell me to redirect to the SSL version. I'll make that request, and then I'll get my actual content that I'm looking for. And with each of these outbound requests, I'm sending cookies that represent my user state on that site. Now, if there's an attacker in between me and the site that I'm talking to, either a router I can't trust, or if I'm in an internet cafe or a coffee shop using unsecure Wi-Fi, that attacker cannot see what's happening over SSL, but they can see that initial plain text request. And those cookies represent my state on the site. And so if you can see those cookies, you can see and you can masquerade as me. A couple years ago, a guy by the name of, I believe it was Eric Butler, created an extension for Firefox called Firesheep that exploited this very risk with that model, where you click the Start Capturing button and it listens to the local network for passing plain text session cookies and gives you a nice menu of all of the accounts that you can own. And so with one click, you could be logged into Facebook, into Google, into Twitter, into Flickr. It was extensible. You just basically define a little JSON object that pattern matches, and you're like, oh yeah, I can now steal people's Hacker News credentials. The existence of this plugin is what led to GitHub going SSL only in the span of like a week. So what do you do about it? Use secure cookies. Normally, when you set a cookie, your web server sends an HTTP header that says set cookie key equals value. You can throw other information on there, tokens to explain like, I want this to last no longer than this duration. I want to scope it to a certain domain. One of the tokens you can add is secure. And when you tell the browser to set a secure cookie, what you're telling the browser is that you never ever want that cookie transmitted over a clear text link. And so at this point, the attacker is completely oblivious to my session history or my session state, and I'm protected. It's all of like, what, a 9-character diff, and you're set. The danger is there's still that initial request where you have to go and learn that you can redirect to the secure version of the site, because most people don't type in https://bank.com. So the attacker can still see that and can modify that outbound request, and they can modify the response, which means you can't actually be certain that you're talking to the site you intend to talk to in the first place. And there are a lot of ways you can weaponize this. Moxie Marlinspike, for Black Hat 2009, I think it was, released a tool called SSL Strip, which was written in Python. It used Twisted. And it monitored those requests. And whenever something would come back, it just removed any links to SSL sites with a link to a plaintext version of the site. So you have to watch out for that. For instance, when I go to bankofamerica.com, you can see in the inspector, my browser makes 3 requests. The first is for bankofamerica.com, which redirects me to www.bankofamerica.com, which then redirects me to the SSL-enabled version of that site. At any of those first steps, an attacker sitting in the same network as I am could modify the response, could send me somewhere else. They could do a homoglyph attack and send me to like bank0famerica.com, and chances are I wouldn't notice the difference. So this is a huge phishing vulnerability. What can you do about it? The answer is to use strict transport security. When I type github.com into my browser, even when I type http://github.com into my browser makes one request to the secure version of that site. And it does that because in the response, GitHub sets a header called strict transport security. Looks like that. What this does is it instructs my browser to never connect to this domain unless I'm connecting over SSL. And by doing that, you completely eliminate that first round trip and the attacker's in the dark. One header, this is like a single Nginx line or a single WSGI middleware, and you can force people to connect to your site in a secure manner. So, fundamentals of doing a better job of transmitting content: use SSL, use secure cookies so people can't eavesdrop on that first request, and use strict transport security to make sure that people are actually accessing your site over SSL. Let's talk about rendering data. We talked about that secure cookie, which prevents eavesdropping on an unencrypted network. But if I'm able to inject a script into your page, I can use the document.cookie object to see the contents of your cookies. This is a problem that's, again, solved by using HTTP-only cookies. You add one more token to the end of your cookie header, HTTP only, and your cookie is no longer visible to scripts on the page. Again, one line, one config change, and you've dramatically reduced the surface area that someone can attack. Of course, it's a problem if somebody can inject arbitrary scripts into your page in the first place, and we tend to address that with input sanitization, escaping things that look dangerous. But this is still one of the most common vectors of attack on the web. And there are things that browsers can do to help you. One of the first attempts debuted in IE8, and it was called XSS protection, funnily enough. You can set a header that says XSS protection, 1 mode block, and what that'll do is it'll instruct browsers that support this header to look for things that look like they may be malicious and block them. It's great. Like, you don't have to do anything more. The only problem is this is based on heuristics. And so each browser that implements this header is going to do it slightly differently, and it may not catch everything. It will not catch everything. So there's another layer of security you can add: content security policies. This is, again, just another HTTP header that you can send where you can say explicitly, by default, I only want to allow content from myself. For images, I want to allow images from myself or from the data URIs. Scripts, I want to allow from myself or from api.example.com. What content security policy lets you do is it lets you define a whitelist of where things can come from that your browser will actually accept. And so if I was able to inject a script onto a page that had this content security policy, the script would not execute because this policy does not allow inline scripts. This is the most important thing you can do to protect yourself against cross-site scripting attacks. At this, seriously, stare at this slide for a minute. This is big. You can just turn off third-party scripts. And most modern browsers will respect that, and you're completely immune to some of the most common attacks. The problem with CSP is that it's a whitelist. So when you're converting your site to use CSP, you need to make sure that you're not going to inadvertently block things that you actually need in order to function. Maybe you need the Google CDN so you can pull jQuery into your page. What you can do while you're developing this policy is to send it with a header called Content Security Policy Report Only, and then in your browser's logs, you'll see a message about everything that policy would have blocked. And when that stops saying it'll block anything, then you're probably at a pretty good place. So at this point, people can't eavesdrop on your content. People can't maliciously alter your content. But there is still one really interesting attack regarding the way content is displayed. I don't know how many of you guys saw the "don't click this" tweet that exploded a couple years ago, where you go to a link, and it's got a button, you click the button, and all of a sudden you've retweeted this message. And the way that worked was by creating a malicious page that had a button on it, and then on top of that button, the attacker embedded Twitter in an iframe, then made that iframe invisible, so when you tried to click on the button on the page, you were actually clicking on the invisible Twitter iframe and retweeting this viral message. That was only possible because Twitter was not setting any sort of framing options. You can, again, with a single header, XFrame Options, say, actually don't allow this page to be embedded in any other pages, or only allow this page to be embedded in other pages on the same domain. There's a third option, XFrame Options allow from URI, where you can say, allow this domain to be embedded in this other domain. but that's not universally supported across browsers. But still, this alone prevents that entire class of attacks. Set it. Unless you have a reason to be embedded somewhere, set XFrame options. What about storing data? Most of us accept some form of user input, store it, and reproduce it on our web apps. There are two main things you can do. The first is to try to isolate user content. I don't know how many of you guys noticed that GitHub in the past year switched all of the GitHub pages from username.github.com to username.github.io. It's because if content is on your own domain or if it's on a subdomain of your own domain, then there are attacks that will allow code to execute in that context. I think GitHub suffered a session fixation attack where an attacker was able to create a cookie on the target machine with a known value, which then allowed you to elevate privileges and do other terrible things. Google does the same thing with their Google user content domain. This is really important. You may think, oh, I'm only allowing people to upload like avatars, or I'm only using Gravatar or something like that. If you're allowing SVGs, SVGs can include JavaScript. And so if you can trick somebody to directly navigating to an SVG, you are then likely to execute JavaScript in the context of whatever domain that file is hosted on. And if that domain is something that you use for other things, that's an attack vector. If it's something that you don't use for your own content, something like github.io or googleusercontent.com, you're fine. The last thing, you fundamentally cannot lose access to data. You cannot have a breach for data that you don't store in the first place. So if at all possible, try to avoid storing passwords. There is no way to win with passwords. Even if you do everything right, you're using scrypt or bcrypt, you have an appropriate work factor, you're using appropriate salting strategies. That doesn't matter, because what that's ultimately doing is protecting the password that the user set. And if you have a significant user base overlap between, say, your site and LinkedIn a couple years ago, or last year, chances are people use the same password on both of those sites. And so you're only as secure as the weakest link in that chain. I have a database of LinkedIn passwords. I can go and try those on your site. I will probably get into at least a handful of accounts. That's not a problem, and you can't be in LinkedIn's shoes if you don't have a database of passwords to leak in the first place. I personally work at Mozilla on the Persona project, which is an attempt to sell you on something that I'm sure you will all love. Mozilla is trying to find an alternative to the prevailing regimes for authentication. Because right now there is this bifurcation between either a username and password, which gives people control over who they trust, but it forces them and it forces you to treat that password properly. Or there's a second option of social authentication, so the Facebook, Twitter, Google login, which again are better in many respects, better from a security standpoint in many respects than handling your own passwords, but they do force your users to authenticate through a specific whitelist of third-party providers, and thus subject you and your users to those terms of service. Persona tries to strike a middle ground. Any email address works with it, but there's no site-specific password. I'd highly encourage you to check it out. But in summary, transmitting data, use SSL and make sure it's getting used by setting strict transport security. Set secure and HTTP-only cookies so that those cookies cannot be intercepted in flight and they can't be intercepted and inspected by malicious scripts on your page. When you're rendering your page, send XSS protection, content security policy, and frame options headers. That will completely inoculate you against entire classes of attacks in the space of, what, maybe 20 or 30 bytes in a header. And when you're storing data, isolate it to its own domain. And if you can at all avoid it, don't store passwords or things derived from passwords. The way you can do that is Persona. So after the requisite shilling, I'm happy to entertain questions for however much time we have.
Thank you. My name is Bill. I'm a front-end web developer. My question is, well, I have two questions. The first one is this available somewhere that we can use as a checklist? And also number two, with the don't store passwords, I find that, well, it's kind of like you have a dilemma, right? Because it's like, do I want to trust my user security to his third party? Not that there's anything wrong with Mozilla, but like, do I want to do like Facebook login or whatever, or do I take this data into my own hands? Which, as you are arguing, there are issues there, but there are also issues with I'm trusting my user login to other people. So what's your take on that? Like, is there just no way around it? You kind of have to decide between one or the other, or do you think there's a third option?
I mean, every site's needs are going to be different. When you're using passwords, you have to presume that users are reusing their passwords. Most people have between 3 and 5 passwords that they use, which means that you're effectively trusting your user's security to all of the third parties that they also connect to. The way Persona is structured, it's very similar to OpenID, but with more privacy protecting measures. It's designed so that the user authenticates with their email provider to bootstrap a public key-based authentication session. And people tend to treat or be willing to treat their email more securely. So something that relies on some sort of third-party account somewhere is likely to survive a little bit better in the case of like the LinkedIn breach. But yeah, you got to make sure that what you do makes sense for your site, your business model, your case. In many cases, actually storing a password is the right thing to do. But if you're doing that, make sure you know what that means. As far as this deck being available for a checklist, the slides have been uploaded to SpeakerDeck under the PyCon Canada account, so they'll be available there. I'll also post them on my blog tomorrow with a textual version of this presentation. Oh, sorry. Yeah, Laura's handling the mic.
So for a lot of these issues, for like the checklist, is all of this covered on the OWASP? Is it OWASP? Is that what it is?
Yeah, OWASP.
Like, I know they have a checklist or whatever of like the most common attacks. I'm wondering if they cover this stuff on there too.
Yeah, OWASP, if you're not aware of it, is a great resource, just a big wiki-based repository of information about security on the web. They will have much more in-depth articles about any of these things. What I want to do with this talk is just make you aware that there are things that you can do. You can tell the browsers to completely protect you against certain types of attacks, and all it takes is a single HTTP header. So I'm trying to get the word out, but OWASP is a fantastic canonical resource for learning about how these things work.
So everything you're mentioning here is excellent, but it assumes that the people who are designing the sites are both competent and care about their user security. And so my question to you, being a Mozilla representative, is how much responsibility do you think the browser creators have to informing their users and protecting them, most of whom are completely ignorant about what is and is not a risky behavior on the part of the people designing the sites that they're visiting?
So the browser vendors are in an interesting place because we have to balance the things that we can do to improve the user security with things that the web as it exists today relies on. So things like HTTP-only cookies, we can't do that by default because there are some sites that still rely on being able to read and write cookies over JavaScript. And if we turn that on by default, it'd break the web for some subset of users. And so we're in a difficult place where we have to balance what can we do without harming users, because oftentimes that encourages more dangerous behaviors. Like, oh, I'll go and turn this feature off altogether. Like the Windows UAC prompts, where it's like, oh, it's annoying again. I'm just going to click allow or go and find the registry hack to disable it altogether, and that doesn't serve anyone. Yeah, so the question is, what about having the browsers inform users and help educate them about security risks? We try to do that where possible in terms of mixed mode content, insecure SSL certificates, things like that. But it's definitely, the onus definitely falls upon the users and the vendors to make sure that people have a good experience. But we here as developers can go a long way in helping people that do care and help protect ourselves. Are we at time?
Yeah, thanks guys so much. Let's give Dan another thanks.
Yeah.